Okay, so this is part 2 of your chapter 6 study guide, second page. So number 14 says sketch one period of the function y equals sine of theta. You need to be able to sketch sine and cosine functions, the parent functions anyway, without the aid of a calculator. So even though you're going to have the aid of a calculator on your test, with it being 18 questions and you having to finish in class, you don't want to be caught in a bind of like, oh, let me just check what sine looks like. Okay, you must know that the parent function for sine starts at 0. Okay, it goes through the origin. And then typically, we remember we do the 4 corners. So we count by pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi. That would be one period of the sine function. It starts at 0, then it goes up to 1. Then at pi, it's back down to 0. At 3 pi over 2, it's down here at -1. And at 2 pi, it is back up to 0. So one period would look like this. If you extend it and you put arrows on it, that's fine to show that it's periodic. But if I ask you for one period, it's okay if you just stop it at those endpoints, so to speak. Okay, the parent function for cosine is very similar, except its range goes from 1 to -1. And the main difference is instead of going through the origin, it starts at the point, the parent function anyway, starts at the point 0, 1. So it starts up here. And then from there, it goes down to 0 at pi over 2, down to -1 at pi, back up to 0 at 3 pi over 2, and then back up to 2 pi. So again, one period, typing a bunch of 8s, one period would look like this. And my curve looks lovely. Okay, number 16, draw an example of a non-trigonometric function that has a period of 6. So a period of 6 meaning it takes 6 counts, so to speak, for it to complete one cycle. When I say non-trigonometric, that means I just don't want you to use sine or cosine waves, so to speak, or any other type of trig function, even though those periods are 2 pi. Okay, so a period of 6, here's what that means. You can literally draw any design if you want, any design. So if I, count by, let's do like 1, let's count by 2s. 2, 4, 6, 8, 10, 12, 16, 18, 20, 22, 24. Okay, so 8, 10, 12. My numbers got a little clogged there, but that's okay. You get the idea. Okay, if it has a period of 6, you can start anywhere. I'm going to keep it simple and start at the origin. And from the origin till 6, I'm going to make just like a little mound. So that's going to be one period of my function. So that means it needs to repeat itself exactly the same every 6 counts. So from 0 to 6, it'll look like that. From 6 to 12, it'll look like this. From 12 to 18, it'll look like this. From 18 to 24, it'll look like this. And then it keeps going, right? So we could show that it keeps going repetitive like that. It doesn't have to start at the origin. It just means after every 6 counts, so right from here to here is 6 as well, it needs to repeat itself. So notice that there are multiple answers for this as well. Mine is just one example. Number 17, determine if each graph below is periodic. If so, what is the period? So periodic meaning it repeats the same y values over and over and over again. So let's look at part A. This graph is periodic. You can see that it starts repeating itself and it looks the exact same over and over and over. So we can tell it's periodic. In terms of determining the period, some of you may say, ooh, I noticed from you can start at the left part of the graph, but again, why start there when you can, or no, let's do that. So, okay, from -2 to 1, I notice this stuff is the same, and then it starts repeating itself again here at -1 and -1 to 0. So the distance from -2 to -1 is 1. Okay, some of you may say, ooh, let me start at 0 on the x-axis, because that's where math is easy. Okay, and then from 0, if I start here, it goes all the way until 1, and then it starts repeating itself again. Well, again, that's a distance of 1. So it doesn't matter where you start counting your period, because it doesn't have to do with location. It has to do with distance. So the period there is 1. For part B, if you look at this wave, there are no repetitions. There's no type of pattern that occurs between these waves. Nothing repeats itself over and over again, so it is not periodic. For C, it's a little bit more sporadic and more challenging to tell compared to example A. However, it is repetitive. You'll notice that from, let's see, like 10 to, so kind of look at where your waves, this is the lowest point, and then it goes up, and then up higher, and then a little lower, and super, super low, and then it goes back down again here, and at this point, it starts repeating itself again. Okay, and then it does its super high mountain climbs, and then it comes back down here, and then it ends, and then it starts repeating itself again, and then same thing. So at each of these minimum points is where the start or the end, however you want to look at it, of the period occurs. So here you're just going to do some estimation. We can tell that it is periodic. If you're looking at the numbers on the bottom, though, from here to here, you know, it's not exactly a number that we can tell given the unit measures. So I just approximate and say, okay, from 10, from about, it looks a little bit over halfway from 11 to 12. So I'm going to estimate that the period is approximately 1.6 in that example. And I would take any in the ballpark. I would take 1.5, I'd take 1.7, as long as you're close to that period. Number 18, graph y equals the cosine of theta only for the interval 13 pi is less than or equal to theta is less than or equal to 16 pi. So this one, if you can do 14 and 15, then you could do 18 and 19 with a couple of edits to those graphs. Okay, first thing, I'm only changing my domain. Okay, so my max is still going to be 1, my min is still going to be -1. But the deal is, I don't want to have to graph from 0 all the way to 16 pi. So if I put this little, surely there's got to be a formal term for that. I just called it a little zigzag. If you put that on your x-axis, you're claiming that you're skipping a bunch of numbers until you start your graph at 13 pi. And then we can count 13 pi, 14 pi, 15 pi, and then we want to go all the way until 16 pi. So here's the deal. I need to know, where are the points that I'm graphing? Are they at -1? Are they at 0? Are they at +1? To figure that out, you can actually use your calculator. Okay, in your calculator, first of all, make sure you're in radian mode and actually calculate, okay, what is the cosine of 13 pi? And if you plug that in your calculator, the cosine of 13 pi is equal to -1. So that's how I know that this first point at 13 pi will start at -1. Do the same thing for 14 pi. Plug cosine of 14 pi into your calculator, and you would get +1. If I do the same thing for 15 pi, I would get -1, and 16 pi, I would get +1. Now, you don't want to connect these points the way that they are, because there's some stuff happening in the middle that you just want to make sure that you get, so to speak. So I would, in addition to, when I ask you this question on your test, in addition to doing these whole pi numbers, I would also break them up into the half pies, right? So 13 pi can also be written as, if you multiply 13 by 2, that number can be written as 26 over 2, right? 26 over 2 is 13, which lets me know that this number is 27 pi over 2. And then 14 would be the same thing as 28 pi over 2. So that means this half would be 29 pi over 2, etc., right? Then 30, then 31 pi over 2. And then do the same thing. If you plug these values, cosine of 27 pi over 2, into your calculator, you would get 0. And then if you did the cosine of 29 pi over 2, you'd get 0. And the cosine of 31 pi over 2, you'd get 0. So remember, if we're going to be counting by pi over 2s, this kind of will help give us a little bit more shape to your curve, to make it a little bit more accurate. So that's the cosine function only from 13 pi to 16 pi. Number 19 is like it, but it is for sine. So I want the parent function for sine, but only for the interval 7 pi over 2 to 11 pi over 2. So again, my y values are at 1, -1. I am skipping some stuff on my x-axis, and I only care to start at 7 pi over 2. So this time I'm starting off with a half. Okay, if I count by another half, 7 pi over 2, then I get 8 pi over 2, which is the same thing as 4 pi. And then I've got 9 pi over 2. And then 10 pi over 2 is 5 pi. Then I've got 11 pi over 2, and that's my end value. That's where I need to stop anyway. Similar to what we did for number 18, you're going to use your calculator to help you calculate, okay, where are the coordinates at these points. So in the calculator, literally type in the sine of 7 pi over 2. If you do that, you'll get -1. So that lets us know that at this first point, we're starting off at -1. Then if you type in the sine of 4 pi, it would give you 0. Okay, and then if you repeat the process for these other 3 points, at 9 pi over 2, the cosine is 1. At 5 pi, it's 0 again. And at 11 pi over 2, it's -1 again. And so there's your curve. Remember to make your curves actually curved and not just draw straight lines from each of those points. Number 20, describe the transformation that would change the graph of the sine function to the graph of the cosine function. To help you with this, you could go back to 14 and 15, and I want to know, what would it take for sine, for this graph on 14, to match on top of cosine? And there are a few answers, actually, but the easiest answer to get from sine to cosine is if we take our sine graph here on the left side, and if we shift it to the left, right, if this peak point here at pi over 2 would match up here at 0, 1, the rest is a cosine function. So the answer, the quickest answer, I'll say, is if we were to phase shift. Remember, that's just a fancy word for a horizontal translation. So if we phase shift to the left by pi over 2, okay, that's the easiest answer. Additional answers, so other answers, I don't even know what that word says. Let me try that again. Other answers. Other answers could include pi over 2 times any number n, when n is an element of the integer. So you could say, oh, let's shift it over 3 pi over 2, or let's shift it to the right this amount. It would land on top of itself again and again and again. Number 21 and 22, I want you to write the equation of the sine function with each amplitude and period. So remember, if you go back to, let me write this out here to the side, y equals a times the sine of k theta plus c plus h. Right now, I'm only changing amplitude and period. So obviously, a stands for amplitude. K does not stand for period. K helps you to find the period, right? So period is actually, so we know in number 21, A is 0.5. The period is found by computing 2 pi over K. So if they tell us the period is 8 pi, then we can say, okay, well, this implies that 8 pi is 2 pi over K, right? If I literally substitute 8 pi in for the word period. And then from here, I can cross multiply, or just multiply both sides by 2, however you want to think about it. And then if I cross multiply, I get, that should say 2 pi over K, not 2 pi over 2. I don't know where that came from. 2 pi over 2. Okay, when I cross multiply, I get 8 pi K equals 1 times 2 pi is just 2 pi. And then to isolate K, we'll divide both sides by 8 pi, which pi over pi is 1, and then 2 over 8 is 1/4, okay, which implies that K is 1/4. So you have two answer choices here, and really they are equivalent to each other, and I might have to make some room. I shouldn't have written here. They're equivalent to each other, but They just look a little bit different. One has fractions, one has decimals. So it does not matter which one you choose as long as you are consistent within your problem, either all fractions or all decimals. So let's do the decimal first. Your first answer choice, y equals plus or minus, right? Because amplitude is just distance. So a negative amplitude or negative, flipping it over the x-axis will also have the same amplitude. So plus or minus 0.5 times the sine of k, we said was 1/4 was a decimal. That's going to be 0.25 theta. So that's your answer using decimals. You could also write it as plus or minus 1/2 times the sine of 1/4 theta. So either one of these will do. Okay, number 22 is just like this one. Amplitude of 6.2, period of pi over 3. So again, amplitude is easy. That's A. For period, we're going to say, okay, the period is 2 pi over k. So I need to solve for k. So meaning I can plug in pi over 3 for period, set that equal to 2 pi over k, and then I can cross multiply to solve for k. So when I do that, I get pi k is equal to 3 times 2 pi is 6 pi. Divide both sides by pi. Pi over pi is 1, and then I get k is equal to 6. Okay, so my final answer for number 22 will be y is equal to plus or minus the amplitude of 6.2 times the sine of k theta will be 6 theta. Number 23 and 24 are very similar questions, except I just changed the function on you. I'm asking now for cosine with the given amplitude and period. So we're going to do the same stuff. Amplitude for 23, we know A is 12. We know in order to find the period, we're going to have 2 pi over k. So that implies the period for this problem is 3 pi over 4. So if 3 pi over 4 equals 2 pi over k, we can cross multiply and get 3 pi k is equal to 4 times 2 pi is 8 pi. Divide both sides by 3 pi. Pi over pi is 1, implying that k is 8/3. So you have a and k. Your final answer would be y equals the cosine, well, I'm sorry, I forgot amplitude. Y is equal to plus or minus my amplitude of 12 times the cosine of 8/3 theta. And notice, guys, sometimes, I'll put parentheses around it like I did in number 22. Sometimes I won't put it there, just like I did for 23. There's really no right or wrong way to do it. Just make sure that, you write these kind of close together so that it's understood that 8/3 theta are inside of the cosine function. Okay, last problem on page 2. I got an amplitude of 0.7, and then I've got a period of pi. So if my period is 2 pi over k, but we know the period is pi, then pi equals 2 pi over k, which logically thinking, okay, hopefully k is equal to 2. If you can't see that, cross multiply. You get pi k is equal to 2 pi, and then when you divide both sides by pi, you get k equals 2. When I say 2 pi, I think about 2 pi. Final answer, y is equal to amplitude plus or minus 0.7 times the cosine of 2 theta. So that concludes page 2.